Ever pondered how rockets manage to defy gravity and soar into the vast expanse of space? Since the dawn of time, humans have been fascinated by the cosmos, and rockets are our key to unlocking its mysteries. At their core, rockets operate on a simple principle: action and reaction, the fundamental law of physics. But how does this principle translate into a machine that can pierce the heavens? Hold on to your curiosity as we unravel the mystery of rocket propulsion. At the heart of rocketry lies a basic principle: Newton's third law of motion. Now don't let the scientific jargon throw you off. This law can be summed up in a simple phrase we've all heard: for every action, there's an equal and opposite reaction. Now let's break it down a bit further. Imagine you're sitting on a skateboard and you throw a basketball. The action here is you throwing the ball, but what happens to you? You move backwards on the skateboard, right? This is the reaction, the equal and opposite movement to your action of throwing the ball. This is exactly what Newton's third law is all about, and it's also the principle that rockets operate on. In the context of rocket propulsion, the action is the expulsion of gas out of the engine. This happens when the rocket fuel ignites and creates a high pressure and high temperature gas. This gas is then forced out of the back of the rocket. Now remember our skateboard example. Just like how you move backwards when you threw the ball, the rocket also moves, but in the opposite direction to the expelled gas. This is the reaction. But of course, the force involved in a rocket launch is massively greater than throwing a basketball. The gases are expelled at such a high speed that the reaction force propels the rocket upwards, overcoming the force of gravity, and voila, we have liftoff. It's a fascinating process, but what's even more remarkable is that it's all based on a principle that was first written down by Isaac Newton in the 17th century. And that's the beauty of science, isn't it? Concepts that were discovered hundreds of years ago are still applicable today, guiding our exploration of the cosmos. So, rocket propulsion isn't magic, it's physics in action. Now that we understand the principle, what about the fuel that powers these rockets? Well, fuel is the lifeblood of a rocket. Without it, our rocket is nothing more than a beautiful sculpture of engineering. But what exactly is this fuel, and how does it help a rocket defy gravity and reach the stars? Let's dive in. There are primarily two types of fuels used in rockets: liquid and solid propellants. Liquid propellants are composed of a liquid fuel and a liquid oxidizer, stored separately until they are combined and ignited. They are complex, yet offer high efficiency and the ability to control the rocket's thrust mid-flight. On the other hand, solid propellants are simpler and safer. They consist of a single composite material that acts as both fuel and oxidizer. Once ignited, they burn at a steady rate and cannot be stopped or controlled. This makes them perfect for the initial boost needed to get the rocket off the ground. Regardless of the type, the fundamental role of fuel in a rocket is the same. When ignited, it undergoes combustion, a chemical reaction that produces vast amounts of gas and heat. It is this gas, expelled at high speed from the rocket's nozzle, that propels the rocket forward. Remember Newton's third law? For every action, there's an equal and opposite reaction. The gas's action is to rush out of the nozzle, and the reaction is the rocket's upward motion. One crucial aspect to consider here is the fuel-to-oxygen ratio. Rocket fuels require oxygen to burn. However, the balance has to be just right. Too much oxygen can make the combustion too intense, while too little can cause incomplete combustion and reduce the rocket's efficiency. So you see, fuel is more than just rocket juice. It's a carefully chosen, meticulously balanced blend of chemicals that transforms our rocket from a ground-bound artifact into a sky-piercing vehicle. Without the right fuel, our rocket is just a fancy piece of metal. Enjoying the journey so far? For more intriguing insights, do subscribe to our channel. Feed your curiosity on all things space and beyond. With our regular updates, you'll never miss out on the fascinating world of cosmic exploration. Now let's get back to our rocket science. Understanding rocket propulsion is one thing, but what about the rocket itself? Let's take a closer look at the anatomy of a rocket. Picture a rocket, and you might visualize a sleek, pointed object hurtling through the sky. But beneath that exterior are several key components that make the journey to space possible. At the heart of every rocket is the engine. This is where the magic happens, where the fuel and oxidizer mix and combust, propelling the rocket into the heavens. The engine is the powerhouse of the rocket, turning stored energy into kinetic motion. Next, let's delve into the fuel tanks. These are the reservoirs that store the rocket's fuel and oxidizer. Their primary function is to supply the engine with the necessary materials to create thrust. They're designed to withstand extreme pressures and temperatures, ensuring the safety of the rocket and its occupants. Then we have the payload. This is the reason for the rocket's journey. Whether it's a satellite, a scientific instrument, or a crew of astronauts, the payload is what the rocket is tasked with delivering to space. It's housed in the nose of the rocket, the most aerodynamically efficient place to carry weight. These are the main components of a rocket, but there are countless other parts, each with a specific function. From guidance systems to thrusters, every piece has a role to play. All these parts work together to make space exploration possible. So we've fueled our rocket and it's ready to go, but what happens next? Well, the journey of a rocket isn't as simple as a straight line to the stars. It's a meticulous process of stages, each as important as the last. Let's delve into this fascinating voyage, shall we? At the crack of ignition, the rocket's engines roar into life, expelling exhaust gases with such force that propels the rocket upwards, defying the grasp of Earth's gravity. This is the first stage, or the liftoff, and it's about raw power. The rocket's thrust must be stronger than the weight it's carrying. Once the rocket is in motion, the next stage kicks in. Here the rocket's speed and altitude increase exponentially. The first stage boosters, having exhausted their fuel, are jettisoned. This is a crucial step, as it reduces the weight of the rocket, allowing it to climb higher. But it's not all about going up. The rocket needs to go forward too. So it starts to tilt toward the horizon in a move called a gravity turn. This maneuver positions the rocket on its path or trajectory towards its destination in space. Now comes the final stage, the deployment of the payload. The last booster is jettisoned and the payload, whether it's a satellite, a space telescope, or a capsule with astronauts, is released into its designated orbit. Throughout this journey, the principles of rocket propulsion are at work, pushing the rocket against the pull of gravity, guiding it on its path, and finally delivering the payload to its destination. And that, dear viewers, is how a rocket defies gravity and reaches space. Space, the final frontier, is within our reach thanks to the wonders of rocket science. We've explored rocket propulsion, fuel, and anatomy today. Thanks for joining this cosmic ride. Enjoyed the journey? Don't forget to like, comment, and subscribe for more fascinating discoveries. Until next time, till next.